Hi and welcome back. In this video, I'll be discussing two questions on electrolytic cell focusing on Faraday's law. Let's begin. Exercise 1. An aqueous solution of copper nitrate was electrolyzed using current of 1.5 amp for 60 minutes at 25 degrees Celsius and 1 atmosphere. Calculate the mass of copper metal deposited at cathode and the volume of gas evolved at anode. Extra information given in this question is the molar mass of copper, which is 63.5 gram per moles. In order to calculate the mass of copper metal, you must begin by calculating the amount of charge that is flowing in the circuit. That can be done by using the formula Q equals to IT. Substitute in the corresponding values. Remember to convert time in minutes to second, and 5.4 times 10 to the power of 3 coulomb is the answer. Remember, next, write out the relationship between the mole of electron and coulomb, which would be 1 mole of electron is equivalent to 1 farad as well as 96,500 coulomb. In order to calculate the number of mole electron passing through the circuit, divide 5.4 times 10 to the power of 3 coulomb with 96,500 coulomb. And the number of mole passing through the system would be 5.595 times 10 to the power of negative 2 mole electron. Next, write out the half equation of reaction occurring at cathode. That would be the discharge of copper 2 plus ions to become copper. From the equation, it can be seen that 2 mole of electrons is required to produce 1 mole of copper. Therefore, 5.595 times 10 to the power of negative 2 mole electrons circulating in the circuit produces 2.279 times 10 to the power of negative 2 mole copper. Now that we have the number of mole copper that is being produced, we can convert it to mass by multiplying it with the molar mass. And there you have it, the final answer for mass of copper. Now let's look at solutions for part B. You were required to calculate the volume of gas produced at anode. For this question, you can start off by writing straight away the half equation of reaction that is occurring at anode, since you have calculated the charge that is flowing through the system. From the equation, you can see that 4 moles of electrons are required to produce 1 mole of oxygen gas. 5.595 times 10 to the power of negative 2 mole electrons are circulating in the system. Therefore, it will produce 1.398 times 10 to the power of negative 2 mole of oxygen. Now that we have the number of mole of oxygen, we can use the ideal gas equation to calculate the volume of gas produced at anode. Now let's move on to exercise 2. Determine the Faraday's constant from an electrolytic cell. Based on the following data obtained from the electrolysis of copper sulfate solution, you are required to determine the Faraday's constant. Initial mass of copper electrode and the final mass of copper electrode is given, as well as the mass of copper deposited. The current flowing through the system is given from the ammeter reading, as well as the time in second. In order to calculate the Faraday's constant, first we must know the number of mole of copper deposited as well as the charge flowing through the system. So begin by writing the half equation of reaction occurring at cathode. From here, the next would be to calculate the number of mole of copper deposited. You can do this by dividing mass over molar mass. Next, calculate the charge flowing through the system by using the formula Q equals to IT. Make sure to use time in second. Now, from the experiment, we can see that 2.33 times 10 to the power of negative 4 mole copper is produced by 45 coulomb. Therefore, in order to produce 1 mole of copper, we require 193133 coulomb. Next, from the half equation, it is clear that 2 mole of electron is required to produce 1 mole of copper, and in terms of coulomb, it would be 193133 coulomb. 2 mole of electron can be also translated as 2 farad. Therefore, 2 farad is equivalent to 193133 coulomb. Since the question is asking you to find the Faraday's constant, that would be 1 farad, and this is equivalent to 96566.5 coulomb. So there you have it, the value of Faraday's constant, very much close to the theoretical value, which would be 96500 coulomb. That's all for this video. Thank you.